Hey guys, and welcome to this week's video on statistical sampling methods. This week for your homework, we are going to go over some different sampling techniques here listed for you. Simple random, stratified, cluster, convenience sampling, and systematic as well. All of these are pertinent to our statistics unit that we probably won't get to cover, but is something really simple that I feel like you guys will be able to grasp pretty easily and have some fun with it. There is no algebra involved with this, so those of you who have complained thus far, this will be your moment to shine. Sampling method. So this first slide here is just to give you kind of some insight into the unit. And specifically, we're only going to talk about 5 specific sampling techniques. Sampling techniques are just different ways to choose a sample to study. Now, you're probably thinking, well, what do you mean by a sample? Samples are chosen when the whole population cannot be studied. So, a population is something or someone or a group of people that you want to study. Things like a census, where technically not everybody in the entire US is asked different questions every 10 years. They go and find a group of people who are supposed to be representative of all of the people who live in the US. And those are the people who get to choose the census. Um, the sampling technique should always give you the most accurate measure that is possible for the whole population. So we want our sample to be representative of a bigger population. So good techniques are the ones in which every member of the population has an opportunity to be chosen for the sample. Just because you choose a sample doesn't necessarily mean that it's a good one. A bad technique, doesn't allow for all members of the population to be representative. So maybe you're wanting to know how the whole US feels about, let's say, a given topic in politics. You're not going to want to ask the people you hang out with because more than likely you all have typically the same feelings, or else you wouldn't really be hanging out with them. So that's not going to give you the best representation of everyone in the US. If all members of the population are not representative in somehow or some way, then the sample cannot possibly tell us how the entire population might really feel or what it would be like. So we have some good techniques and we have some not as good techniques. The first one we want to talk about is going to be a simple random sample. It's called SRS for short. And the first thing that you would need to do for a simple random sample is to assign a numerical label to all individuals of the population and then randomly pick numbers. So I might pick names from a hat. I might use a random number generator. I might use a random number table. I'm typically going to assign students or a group of people numbers and then use some kind of random generator other than myself to pick the names. So this is just a picture to help you kind of conceptualize what's going on. So our population is all of these different dots, purple and green. But our sample would be randomly picked out from a hat, and it would be just these green ones. Simple random is just exactly what it sounds like. It is just that random. Another good technique is called the systematic sampling technique. The first thing you do is you randomly select a beginning number. So in this case, we're going to pick the second one. We're going to start with that person, and then we're going to select every nth, or in this case, this example, the third student after. So second, 1, 2, 3, we're picking number 5. 1, 2, 3, number 8, 1, 2, 3, number 11, and then 12, and so on and so forth. If it stops, that's fine. We're just going to pick these 4 to represent that whole population. Now remember, this is trying to make it so that we are picking the best sample possible for a given population, and sometimes being random is part of being a good sampling technique. So systematic, if you start seeing things like every third person, every 20th bottle, every um, 57th person, all of those are going to be your systematic because you're assigning it a very specific approach and you're doing it systematically. Stratified. Stratified and the next one, cluster, are probably going to be the ones that give you guys the hardest. They're very, very similar. So stratified, the first thing you're going to do is divide your population into groups. Doesn't necessarily matter how you do it. You could do it based on gender, you could do it based on age, you could do it based on hair color. It doesn't matter how you group your population so long as they are broken up into groups. So in this example below, maybe they broke it up by classes like we have listed here. And then you're going to randomly select members from each one of those groups. So notice I have 1, 2, 3, 4, 5 different groups here, and I have at least one from every group. Our example here, select 10 freshmen, 10 sophomores, 10 juniors, and 10 seniors. So obviously our student population would be broken up by grade level, and then we're going to pick 10 from each grade level. So I want to pick some out of all or every group. So some out of all is for stratified. Cluster is very similar. We're still going to divide our population into groups, still have those 5 groups here. But then I'm going to randomly select either 1 or 2 groups or a few groups and interview or ask everyone in that group or all. So I'm going to use all from some of the groups. So maybe we randomly select homerooms off of B Hall, and then we're going to ask every student on B Hall what they want for the prom theme, whatever the question is. But we would randomly select which hallway. So we chose B. So these would be the different hallway groups. This might be upper B and this might be lower B. And we would ask all homerooms on those hallways. So stratified is some in all groups, but cluster is all from some of the groups. So those are kind of swapped. Convenience, it's not the best technique. It is a technique, but it's not the best one because remember, we want to reach people who are representative of a whole population. And sometimes if we pick things that are localized to us, like we talked about our friend group just shortly ago about politics, sometimes it's not the best representative. So convenient sampling is where you select individuals that are easy to reach. This might be telephone surveys, mail-in questionnaires, mall questionnaires where somebody just grabs you as you're walking by and is like, hey, what do you think about the new Jordans? Or hey, what do you think about the new Beats? All of these, asking classmates, walking down the street, asking your neighbors different things, all of these don't require a whole lot of effort. It'd be like if I just poked my head out of my classroom and said, hey, anyone who's standing here, what do you feel about free homework passes? All of that doesn't require a lot of effort, so it's not the best technique. Not that it always requires a lot of effort, but it's just not going to give you the best representation of an entire population. So in this case, this would be you or me, and I'm going to ask the people around me. So if we look at our picture here, we can notice like some of the people who are further away, it's not reaching some of our outer population, and it's not always the best grouped. So convenience is typically a biased sample. So it's like saying a lot of you are biased towards the Apple products because a lot of your technology is Apple. You know, well, we don't have really iPods anymore, but your iPods were all Apple. Your TV might be Apple. Everything was Apple. So you would be biased towards Apple products because you already have a lot of them now. Why wouldn't you get the next Apple product? Um, Bias could also be, let's say, if I asked you about a certain representative who wants to run for a local office, and he comes and he makes the announcement that I'm going to fix all of our really bad, terrible, awful, no good roads. Well, he is giving you a bias that, first of all, he's already put the idea in your head that the roads are not good. Whether you thought they weren't before, you definitely think they're not good any now because he just gave you that idea. Now he's also told you that he wants to fix them. So you are now biased to think that the roads are bad, he wants to fix them. So, hey, you probably want to vote for him because he's going to fix bad roads. This is where your research and stuff comes in, to see if the roads are actually bad and if we should spend the money on those kinds of things. So bias can come in a couple of different ways, but usually bias is not good in sampling techniques or in a given experiment because you want to keep it straightforward. You want the facts and just the facts. You don't want to be swayed one way or another. So below, or at the top of your page, is this flow chart, and it's how to decide on which technique is being used. So the first thing and the easiest way to go about this is to decide if the technique being used is convenient or not. Are they asking people local to them? Are they walking down the street? Are they sending in a mail questionnaire? Is it convenient to that person who is asking the questions? If it's a no, now we want to ask if our population is being broken up into groups. If the answer is yes, am I doing some of every group or all groups? Then it's going to be stratified. Am I asking all of some of the groups? Like, am I asking only freshman and sophomore? Am I asking only senior citizens in a nursing home? Some group that is broken up by a certain quantifiable variable like age, gender, those kinds of things? And am I asking all of only some of those groups? If your population is not being broken up into groups, am I breaking it down by every third, every fourth, 21st? If I'm breaking it down systematically, then obviously systematic is our technique approach here. And if I'm doing none of those, but I'm doing something like putting names in a hat, making a list, and using a random generator, all of those are going to be indicative of your simple random sample. The last thing here is we have some examples for you guys. Sometimes the best method is just to go through them and to give you hands-on experience with how to approach these so that in the next 10 or so at the bottom or on the back of the page, you'll be more successful. So Glamour Magazine collects data on its readers by asking them to fill out and send in a survey from the March issue. Now, I wouldn't have to do a whole lot of work as a surveyor to put it in the issue, send it out, and whoever wants to answer it can answer it. Not doing a lot of work. It's only going to be localized to the Glamour Magazine readers. So this is definitely going to be convenience. Number 2, a farmer divides his orchard into 50 subsections, so 50 groups. He's randomly selecting 4 of those subsections and samples all of the trees within those subsections. So I'm breaking up into groups, but I'm only going to pick 4 of those groups and survey or sample all within those 4. So this is going to be your cluster because it's all of only some of the groups. Number 3, a group of lobbyists has a list of 100 senators. They decide to talk to every seventh senator on the list about their position on raising teacher salaries. So here they have a systematic approach to a list of people. The systematic, it doesn't matter what the number is, it's always going to be systematic when it's broken down like that. Number 4, a teacher puts all of her students' names in a hat. Ooh, I see names in a hat. That should automatically tell me simple random, but let's just keep reading to make sure. She's then going to select 3 names from the hat these students will take a standardized test. Well, it'd be pretty unfortunate for the 3 who get picked, but she put names in a hat, simple random, always. The president of a college randomly selects 2 students from each department to serve on a student advisory board. So, president of a college, 2 students from each department. Department is going to break the students into groups, and then 2 from every department. This is going to be stratified because I am doing sum of all groups. Number 6, select some rows in a parking lot and survey each car in the row. So the whole parking lot is broken up by rows. Rows are going to be our groups. And then we're going to survey every car in that row, but only some of those rows. So I'm picking some of all cluster. Start with the room number 8 and survey every 5th room after that in a school. Systematic. Randomly select 5 elementary teachers, 5 middle school teachers, and 5 high school teachers. So again, we're clearly being broken up by elementary, middle, and high school, but then we're going to ask only some of each group. So this is going to be stratified. Number 9, we're going to choose subjects using a random number generator. Choose subjects. So we really don't even know what we're testing, but we know we're using a random number generator. That's always going to tell us to use a simple random sampling. Number 10, start with the patient number 56 and survey every 37th patient after that at a given hospital on patient care. 37th, we started at 56. This should be systematic. Number 11, we're going to randomly select 5 students from each major offered at a college. So 5 students from each major. We're going to break up the student body by majors, and then we're going to select 5 from each of those majors. This is also going to be stratified. Number 12, we're going to survey all juniors and seniors about how to maintain the student parking lot. So this doesn't give us a whole lot of information, but we have to kind of dig into it. So they're surveying all of the juniors and seniors, meaning they broke up the student body by class. So I have juniors and seniors. The other 2 groups would be freshmen and sophomore. They picked 2 of those groups and asked all of them from those groups. So all from only some of the groups is going to be your cluster. So again, I hope that this has been really kind of interesting for you guys. It's very different from what we've done so far in Math 3. If you have any questions or need clarification on anything for this homework, please don't hesitate to ask myself, Miss Mann, Ms. Hinchman, or Ms. Jennings, and we would love to help you guys. I hope you enjoy this homework this week and at least get a break from all the algebraic portion of Math 3.